Henderson-Hasselbalch equation, this whole situation was kind of confusing. I finally figured out what to do. I finally understood what it is. Then I finally figured out how to explain it to you. So I decided to film this part 1 of this course right now because I've freshly understood this and I don't want to forget it, right? So first things first is, let's talk about the first learning objective that says describe the drug-based factors affecting rate and extent of absorption of the drug. Now over here we already have studied the factors affecting absorption. Let's now individually talk about it. We all know absorption means moving from one site, route of administration site, to the inside of the cell or inside any compartment. Okay, that's absorption. So what are the drug-based factor affecting the absorption? The drug-based factor, not just like what's going to be our body-based factors. No, it's going to be drug-based factor. So remember, I made a mnemonic for this. SLICD, sliced. Okay, sliced factors affect the drug getting absorbed, which means what inside the drug, what are the properties of the drug which will encourage it to get absorbed or discourage it to get dissolved. That's basically what they're trying to ask you. Okay, first things first is size of the drug. This is very easy. We already discussed that. The larger the size, the more difficult it is, and the example of that is a protein or a heparin. Okay, smaller the size, easily it will get absorbed. Next is the L, lipid solubility. How lipid soluble? The more lipid soluble, the more absorbability. And how do you know if it's more lipid soluble? The less, this is coming to our second part, the more the molecule is uncharged or unionized. So ionization also affects how soluble or how absorbable the drug will be. Okay, this is also known as permeable. Okay, so ionization is also one of the factors. Now you guys will tell me, if the drug is more ionized, will it be more easily absorbed or not? No, uncharged forms are more attracted to go inside the cell, because the ones that are charged, they're just like very like active and they act like beasts. Okay, and they're just like dangerous and nobody wants charged people around them, right? So keep it in mind in that way. Like, that's so rude of me, I'm judgmental. Anyway, my point is that a person that's like complete psycho, that's so rude of me. Now I'm just insulting psycho patient. Guys, Gen Z life, you can't even say anything to anyone because you can offend anything and anyone. Anyway, point is that if someone's crazy, you obviously want to stay away from them, which means ionized person is a charged person and he's crazy. I'm telling you this over and over again for a reason, because this is important for you to know. Okay, how do we know something is ionized or more charged? I will talk about that in a while. The other factor include the chemical stability. I've already talked about it. The more some drugs are not soluble, like they're scared of the stomach acid. Same point in episode 1 that I talked about, factors influencing drug route, right? So chemical stability is over there. We talked about that. The more unstable someone is in the acidic environment, then it's less likely to be absorbed. Obviously, it'll die before it gets absorbed. Coming to dosage forms, some liquid suspensions are more absorbable than tablets. So that's a dosage form. But now our purpose today is to talk about this ionized form. We're trying to get to the bottom of this objective. Predict the relative permeation, meaning absorbability, okay, of a useful weak acid, weak base from knowledge of its pK/pH of the medium using Henderson-Hasselbalch. What the heck was that objective? So this LO itself is so confusing, but you will understand it in a while, because I'm going to explain it to you in the best way possible. Okay, so it took me a while to just understand this objective in the first place. Now, let me make it simple for you. Okay, so now all we're doing is we're just zooming into the part of a drug absorbability or drug permeation in its ionized form. Okay, ionized. Now listen very carefully. What are we trying to determine? Let me just come to this part. We are trying to determine how absorbable a drug is. How can we know how this drug will absorb more readily or less readily? We can know if it's ionized or unionized. So if we have knowledge if it's ionized or unionized, what's predominantly existing? Is it existing more in its charged form or non-charged form? Only then we can decipher if it's good absorption or bad absorption. How can we know if this drug is ionized or not ionized? And that takes us to the first part, which is there are two factors that are going to tell us whether the drug will be ionized more or unionized more form. Does that make sense, guys? Those two factors are the pH and pKa of the drug. Remember, there are two factors that determine will the drug be in its charged form more or in its uncharged form more. And those two factors are the pH of the surrounding environment. So for instance, let's take this figure over here. There is a, let's suppose this is the environment, this environment. Now, this is a acidic environment. So pH of this environment and how good is the drug inside this. So the pKa of that drug also known as the ionization constant of the drug. These two factors, the drug itself, what is its pKa and what is the pH of the medium at the moment, whether it's in the stomach, whether this is the skin, whatever it is, first tell me what is the pK of the drug, what is the pH. This is in our control. We can know these things. Once we know these two values, we can tell what can we tell? First, we'll be able to tell how much will be ionized, and in turn, we can tell how its absorption is going to be. Now, coming to the depth of this concept, let's go in deep a little bit. What do you mean by ionized and unionized forms? For instance, let's talk about weak acid and weak base. Majority of the drugs are either weak acids or either they are weak bases, okay? So, when something is a weak acid, what does it mean? It just basically means, remember one thing guys, there's a biochem or chemistry rule that whenever an acid is very strong, it will always exist in its broken form, which is in its ionic form, whenever something's strong. But when there is a weak acid, it will exist 50-50. Weak base 50-50. Strong base completely in its ionic form, okay? Now, coming to weak acid and weak bases, okay? Weak acid means, let's talk about the equation. This is suppose a weak acid. HA, we all know that acid has a proton, right? So, HA, this is a weak acid. It remains dissociated into its H positive form and A negative form. So it dissociates. So what I was trying to tell you is that strong acid normally remains in this form, right? But when it comes to weak acid, it's 50-50. 50% this exists, 50% this side of the equation exists. Okay, so my point is that which side to us in drug absorption, what matters is which is the uncharged form. So we all know that this is the uncharged form. This has no charge over it. So HA is the more absorbable form. Okay. Now coming to a weak base, similarly when a base meets with a H positive, it becomes a protonated base. Okay, this is a weak base formula. Whenever a base is put into like a medium, it usually it's dissociated and its full form are existing 50-50. Okay, so this is, you should know the basic formula of a base and an acid when they're like, in a liquid form. Okay, when they break off. Okay, so now we know 50-50. Okay, now which form is uncharged? This side of the equation is uncharged, or the deprotonated form of the base is uncharged or unionized. First, understand these basic terms. The protonated form in an acid is the uncharged one, whereas the deprotonated form in a base is the uncharged one, the unionized one. So what is more absorbable? In a weak acid, the HA is going to be more absorbable part of that acid. In a weak base, the deprotonated or the B form will be more absorbable. So what are we trying to determine? We're trying to determine, obviously this is like an ideal situation that will exist in 50-50. But the truth is pH, what we want to know is that pH and pKa are the ones that are going to determine whether this side of the equation will dominate, whether this side of the equation will dominate. Okay, now let me explain to you how.